Hey there! So we know already that Apache Spark is a great tool to transform our data, especially if we've got a lot of data. Think about big data. And the tool we know that uses Spark under the hood that we've been using so far was Azure Databricks. And it's a pretty good tool. It does the job very well. The thing is that Databricks is not a product developed by Microsoft. And in your company, in your project, you might have some rules that don't allow you to use such third-party solutions like Databricks. What then? How to use this Spark without the need of setting it up on your own, which is difficult. And the answer is use Spark pools in Azure Synapse Analytics. And that's the topic for today. So let's get started. Alright, so today we're gonna talk about Spark pools in Azure Synapse. But before we go to this topic, let me give you one update. So you asked me multiple times about how many episodes I still plan to record. Because you want to take the exam as fast as possible. And that's reasonable. So what I'm going to do from now on would be to focus on the content that is needed from the exam point of view. And I will focus on this part only. Just to record the stuff so you could take the exam as fast as possible. Obviously, once it is done, this core part, I will revisit those topics that are not needed from the exam point of view, but I believe that you should know them as a data engineer. So it will be there, don't worry, don't panic, but let's move it aside. And let's focus first on the stuff for the exam. Alright, so let's get back to Spark. So Apache Spark, this open source framework, is a great software, great engine, great tool to process your data. The thing is that it is quite difficult to use in its native form. It's quite complex to set it up properly and then to use it. That's why various companies like Databricks decided to provide a solution where you could start using Spark in a very easy way. Like you saw that it took me just a few minutes to provision a cluster inside Databricks and then start writing my transformations that use Spark under the hood. So it is super easy, this managed Spark. And the alternative to Databricks from Microsoft side is Spark pools inside Synapse. And we talked about Synapse already when I was talking about pipelines. So let me draw one thing, just to give you a context what Synapse is. So Synapse Analytics. Synapse Analytics. So Synapse is this tool, this service in Azure that combines multiple capabilities under the same hood, under the same UI. So according to Microsoft, it should be your one-stop shop for all your data analytics needs. You shouldn't have to leave Synapse and use some other services. Everything you need should be contained within Synapse. And to some extent it is true. And Synapse has those multiple parts inside. The one that we have been using so far, it was pipelines. And pipelines, basically, it is the same as Data Factory, so the same as ADF. And it was used for data transformations. Sorry, not transformations, data ingestion. So it is used basically for data ingestion and orchestration. Because Data Factory and pipelines in Synapse, they do these two things pretty well. Orchestration. Great. But apart from pipelines, we've got some other parts of Synapse. And one of them is this Spark pool. So Spark pool or Spark pools. And this part is basically a managed Apache Spark. So again, the goal here from Microsoft was to make using Spark very easy. Similar concept that Databricks did, but Databricks did it better, simply put. But you will see that in action soon. So Spark pools, they are used, as you can guess, for data transformations. So data transformations. And today we'll focus on this part. There are some other parts as well of Synapse, but we'll get back to them later. Today, let's see what those Spark pools are and how they compare to Databricks. Basically, we will try to do the same steps with our replicable data using Synapse that we did using Databricks. So we will be able to compare these two. And now, one of the selling points of Synapse was that, well, it integrates with other Azure services very nicely because it is the same ecosystem, the same company that developed them. Those services like Azure Machine Learning, Power BI, Microsoft Azure Active Directory, now called Entra ID, storage accounts, key vaults, and yes, it integrates. You will see this in action. All right, so enough talking. Let's jump into Azure Portal to show you how it looks like. So I have my Synapse workspace. So this is my resource that I created. And here, just to open this unified UI, I will click here on Open Synapse Studio button. And this opens a new website that we've used previously to create those pipelines. So here on the left hand side, I should have my pipeline. That's the one that we used to grab minifix data from replicable REST API. So it was there. It is there still. But today we are not going to focus on pipelines. Today I want to show you those Spark pools. So the first question is, what is this Spark pool and how to create it? So you can think of a Spark pool as something similar to cluster from Databricks. So basically it's your compute power that you will use to run your queries on your notebooks, and it uses Spark under the hood. So let me show you where you can create it. So if you opened Synapse Studio, then you should go to the Manage tab. And here we've got Apache Spark Pools tab. And here I will just create a new pool. Think of it like creating a new cluster from Databricks. So what options do we have here? So first of all, let's give it a name, like demo pool. Then we've got to choose a node size family. And basically, we've got only a single option called memory optimized. It tells us which family of virtual machines should be used as our worker nodes and driver node. So you should remember that in Apache Spark and in Synapse and in Databricks, we have this main node that is used as our interface, and then a number of worker nodes that execute the stuff we want it to do. And the same stuff applies here. Then we have to indicate, all right, so how big our nodes, our virtual machines should be. And obviously, the bigger node, the more you will pay for it, and at the same time, the more powerful it will be. But to keep it cheap and small, I will choose the smallest possible node size, which is small, 4 vCores and 32 gigabytes of memory. Then we've got auto scaling that we can enable, something similar that we had in Databricks. So basically, we can decide if we want our worker nodes to be dynamically allocated. If there is a workload that needs more compute power, then yes, those workers can be automatically created. So for example, right now, in my current configuration, I would have somewhere between 3 and 13 nodes in total, and it will be up to Synapse to decide how many of those nodes are necessary. And if we compare it to Databricks, so let me start creating a new cluster. So it is something similar that we have here. Again, we decide which worker type we want to use and how many of them we want to have. This auto-scaling exists in Databricks as well. But take a look, in Databricks, we've got a lot of options, way more than in Synapse, at least when it comes to selecting a type of our workers. But that's fine, let's go with our Spark pool creation. Now, I want to keep it small, so I don't need auto-scaling, so let me disable it. And let's make it as small as possible, as cheap as possible. So I will try to move the slider to the left. And take a look, that actually the smallest pool I can create will consist of 3 nodes. I cannot make it smaller. If I try to set it to 1, it will be changed to 3. So it means that the cheapest, the smallest Apache Spark pool in Synapse will have 3 nodes, master node and 2 driver nodes. All right. In Databricks, we were able to create this single node cluster, which is super cheap. In Synapse, sorry, not possible. You will always have at least 3 nodes. What is nice though about Spark in Synapse is that we get an estimated price already, which tells us that it will cost about 2 euros per hour once it is up and running. So pay attention to this. So the price is something that we'll have to monitor, just to not make it too expensive. So let's move on to the additional settings tab. And here we've got this automatic pausing options that is super important. Again, something similar to what we had in Databricks, that if there is no activity on my Spark pool, I want it to be automatically shut down, just to reduce my costs. And I will leave it to default value of 15 minutes. That's totally fine. Then we have to select, alright, which Spark version we want to use. And take a note here that the newest Apache Spark version that is available in Synapse is 3.4. And let's compare it to Databricks. In Databricks, I have a possibility to choose Spark 3.5, newer version, and that's a long-term support version. So, Databricks is better at adopting new versions of Apache Spark. And you have to remember that Apache Spark is an open source project that is developed and released independently from Databricks or Synapse. And every new release of Apache Spark, it brings some new cool features. So the sooner this new version is adopted by Databricks or Synapse, the better for you, because you can start using these features. And actually, it was always the case that Databricks was faster in adopting those new versions. Synapse was always behind. So it's not a surprise that it is still the case. And actually, if you take a look at guys who commit to this open source Apache Spark project, you'll notice that actually there are a lot of guys from Databricks company who create new versions of Apache Spark. And I believe that Databricks is one of the top contributors as organizations to Spark. So basically, because they create new versions of Spark, they know exactly what will be released in those new versions, how it works, and how to use it in their products. So basically, Databricks will be always, or pretty much always, the fastest company to onboard new versions of Apache Spark. That's the case. So if you want to have those new shiny features from new Spark version, then Synapse is probably not the best option. There are other reasons to maybe not use Synapse, but that's just one of them. But fine, let's continue with our cluster. So let's choose the newest version that exists, 3.4. And the rest of the stuff, let's leave it as it is with default values, and let me create our cluster. Now, it will take a few minutes to create, but that's fine. In the meantime, what I would like to show you is linked services that were defined in Synapse. Because you should remember, I hope, that when we were creating those pipelines in Synapse, we had to define linked services, those connection strings. And what I did was to create this ADLS Gen 2 linked service, which basically it points to my data lake. That's the data lake that stores data ingested from a replicable. And that's great. And we will reuse this linked service soon. But apart from that, what we have is a linked service to the Synapse Analytics workspace. Alright, not important at this moment. And we have linked service to yet another storage account, to yet another data lake. This one, this Synapse DP203 table demo workspace default, default storage. But what is this workspace default storage? So basically, when we are creating a new Synapse workspace, we have to indicate a data lake, not just a storage account, a data lake that will be used as a primary storage. And actually I can show it to you. So let me start provisioning a new Synapse. And one of the options that we've got to provide is this one. The select data lake something. And the tooltip says that this account, this data lake, will be our primary storage for the workspace. And it will hold catalog data, whatever it is, and some metadata. And soon I will show you why this data lake is needed. And when I was creating this instance of Synapse that I've been using so far, I decided to create a separate data lake, not the one that I've been using for data ingestion and transformations. So this workspace default storage, this linked service, it points to my primary data lake. And actually, if we check its properties, it points to a data lake called Synapse ADLS Gen 2 Table Demo 1. Beautiful name, but that's how I called it. As always, name of a data lake, name of a storage account has to be globally unique. Alright, and now on the left hand side, we've got various shortcuts. And the one that I would like to show you today is this data tab, because it has some nice features. So let me show it to you. Let's close the pipeline. And now this data tab, it has two inner tabs. This workspace that contains something called Lake Database. We'll get back to this. And we've got this linked tab. So let's move on to this linked thing. And here basically you will see all linked services related to data that you have defined in your workspace. So what I can see here is the linked service to my primary storage account and a linked service to my data lake that stores data ingested from a replicable API. And now, at the beginning, I told you that one of the nice things about Synapse is that it it integrates various features together. And according to Microsoft, you should be able to do everything you need using this single UI. And actually, in this case, this is true. So this data tab, it allows me to browse the content of my data lake without leaving the UI, which is super cool. So here, I can show you that yes, on my data lake, we've got those various containers. And for example, we've got this raw container to which we ingested data using a pipeline. So let's see if this data exists. And if I click on a container, then in the middle, I will see its contents. So let's go into our replicable directory, into minifix, and yes, we've got some JSON files, the stuff that we've ingested some time ago. Now, maybe you haven't noticed, but I didn't configure any security here, any authentication. This integration with data lakes, it just worked out of the box. In the future episode, I will show you why it works, but for now, let's just keep using it. And now, the cool thing about this integrated browser is that if I right-click on a file, in this case, this minifix.json, then I can preview it, see what data I have. And now, because it is a JSON file, it doesn't look nice. It's just a bunch of a text. But we have this capability to quickly check the contents of the file. But what is even better is that I can right-click on it and then generate a new notebook that will load the content of this file to a data frame. So let's do this. And now what we have here is our notebook experience in Synapse. Something similar conceptually to our Databricks notebooks. But honestly, the UI here in Synapse is compared to Databricks, it's so hard to use it. But let's try. Let's try to do something. So first of all, I will attach my notebook to some compute power, to our Spark pool. Something similar we did in Databricks when we were choosing a cluster on which we would run our code. And here in the middle, we've got a choice we can use to select our pool. And the one that I created previously, 10 minutes ago, it was this demo pool. So actually, let me run this cell because I know it will take Synapse few minutes to spin up this cluster. So I will click on this run button next to my cell. And let's wait for the Spark pool, for those VMs to be created. And in the meantime, let me talk a bit about this UI, what we can see here. So the UI is pretty simple. It has way less options than Databricks. So basically what we have here is a drop-down with a selection of our Spark pools, our clusters, to think about it conceptually. Then we can select a default language for our notebook, something similar to what we had in Databricks. And take note that we have basically the same set of languages that were available in Databricks. So we have PySpark, we've got Scala, we've got Spark SQL, and we've got R. But what is new is this .NET Spark C#. And that was something that was unique to Synapse Spark pools, that we were able to write our notebooks using C#. Pretty cool stuff. This didn't exist, and it doesn't exist in Databricks. Now, the thing is that support for this C# language was quite limited. So many things were just not possible to code. But today you can see this option is grayed out. Why? Well, simply put, it is no longer supported. Sorry, it was in the past, but not anymore. And if we go to documentation about this .NET support in Apache for Apache Spark in Synapse, you will see an information that it is no longer supported since Apache Spark 3.3 and above. And because I decided to choose the latest Spark version that was available in Synapse, which is 3.4, therefore C# is no longer available. Sorry, that's the truth. Alright, my Spark pool is still starting, so let's move on. We've got a window to view various variables. Right now I don't have any. We've got some options to add comment, some place to add comments to my notebook. We've got an option to add execution of this particular notebook to a pipeline. We'll revisit this in a future episode. Then we've got some properties like name and description of a notebook. And basically that's it. We've got nothing more. So as I said, the UI is pretty simple. There's not much we can do, at least in a graphical way. Alright, and I can see that the Spark pool is ready, so it took like 3 minutes to spin up my pool, and now the code is being executed. And actually, this long time for Spark pool to be created, it was one of the things that many people complained about for Synapse, that it is just taking too much time. But apart from that, the code has been executed. And it was super easy. So I just had to right click on a file, just import it into a notebook. The code was generated and I was able to run it. And it works just fine. So that's my data from my JSON file. And we have these arrays of objects stored as a results column. So pretty much it works, right? Because please remember that under the hood, it is still Apache Spark. Now, one big difference between Synapse Spark pool and Databricks is that in case of Synapse, it uses pure unmodified Apache Spark, the open source version. While Databricks, it uses a modified version because they added a lot of enhancements on top of this native open source Spark. For example, they have Photon engine that makes data processing faster and some other enhancements as well. They don't exist here in Synapse. So if you would like to move your code from Databricks to Synapse, please remember that if you used a feature that exists only in Synapse, it is not a part of Spark, then it will not work here in Synapse. Alright, so we were able to read this data from my data lake. Fine. So what I would like to do is to go through this notebook that we used previously in Databricks when we were saving the data to a data lake. Let's just see if we will be able to replicate those steps, at least some of them. So let me copy the first cell that is used to display the contents of my data. And here the option to add a new cell is to scroll down, and somewhere there, oh, there it is, this hidden button to add new code cell. Again, not very intuitive. And sometimes it's not that easy to find this place. It's not always visible. Come on. Yeah, there it is. So let me paste the code and let me try to run it. And it failed. Why? Because I was trying to use dbutils. And dbutils is a stuff that was written by Databricks. It doesn't exist in Synapse. But what Microsoft did was to create its own version of dbutils, and they called it MS Spark Utils. and it has this file system list function that should work. And yes, it worked. I was able to list the content of my raw container on my data lake. The way it was displayed is not that great. If I recall correctly, it looked way better in Synapse. Actually, yeah, here we've got this nice table, while in Synapse it's just a text, so not that great experience from developer point of view. Then let's copy yet another cell, and this cell is used to read data from my data lake, then explode this results column and make it available for SQL statements as my data temporary view. And let me run this. And this one should work just fine, because this is just a pure Apache Spark command. It doesn't use any of Databricks stuff. So yes, it was executed successfully. So let's move on. Then we've got a cell to query this data and to transform it using SQL or Spark SQL. So let me copy it and let's try to execute it. And it failed. It failed because, well, it doesn't recognize the stuff that we want to do here. And the reason is that in Synapse, we've got to use %% SQL to change the language to SQL. In Databricks, it was just a single SQL. And take note that in UI, there is no option to change the language in a graphical way. We have to just code it. Like so. In Databricks, we've got this nice language picker, which is, again, a small thing, but from user experience point of view, they matter. But in Synapse, sorry, you've got to code everything. So let's execute it. And yes, it worked. So it means that, again, in Synapse, I was able to use the data that was registered as temporary view in one cell and use it in another cell using SQL language. Again, because it uses Apache Spark under the hood. So it should work, and it really works. So that's our data that has been transformed. These arrays have been exploded, some data types were changed, and so on and so on. So it works. What we did next was to save this data as delta on a data lake. So let's try to do this. So let me add a new cell and let me just change a file path. So I will call it minifix_synapse. And let's run this. And it failed because Synapse doesn't have a clue what this SQL df data frame is. And take a look how it worked in Databricks. So in Databricks, whenever we execute some SQL statement, their results are stored in this SQLDF data frame. So I can use it just like this. In Synapse, sorry, not possible. So what I will do instead, I will be to execute explicitly this SQL statement and assign its results, basically this table, to my data frame. So let me copy this statement. Let's add a new code cell. And I will call it dataframe2 equals to Spark SQL. And then let's provide our query. And because I know it will be a multi-line query, I will use those triple double quotes, like so. And this time, the content, the results of my query will be available in dataframe df2. And then I should be able to use it instead of this _SQL df. So let me run it. And this time we have no error, something is happening, and hopefully our transformed data will be saved on a data lake in this minifix_synapse directory. And it's taking some time. Synapse Spark is doing those transformations and it finished. And now what is cool about Synapse, and I will keep repeating this over and over, is this integrated data lake browser. So I can go to create a directory, I believe. We saved it to created. Yeah. So we saved the results to the created container, replicable, and there it goes. We've got this minifix synapse directory. And indeed, data was saved as delta, and I can tell this by this delta log directory, and our files are using Parquet file format. Great, so the saving operation worked just fine. So then let's try to read it from our data lake just to verify that it really works. So let's go back to our notebook and let's just update the path just to make sure that we'll be reading the code, that the data that was saved by Synapse. And it should work without any issues. And it works. And again, inside this notebook, I didn't configure any connectivity, any security part. It just works out of the box. All right, cool. So let's move on. You should remember that we've got different ways we can use to save data to a data lake. The one that we've used so far was without creating this table in a metastore in our catalog. But we've got those additional options when we'll register it. And to make it work, let's create a database in Synapse. So let's do this. And again, I will have to add this second %sign. Let's create a database called PiotrTDemo. And you might start wondering, all right, but where it will be created? But we'll get back to it in a second. In the meantime, let me grab a query that actually creates this table and populates it with some data. So the database has been created. So let's add another cell of SQL language. Let's create a table called minifix_synapse, or actually, because we don't have any tables yet in Synapse, it can be without this synapse suffix. And let's run it. And in a second, we'll see if this table was created and if it contains any data. So let's wait a second for Synapse to finish, and it succeeded. So the next thing to do would be to try to read data from this table. Again, let's add %, and let's run select star from my table. All right, and it worked. We have the data. So for sure, data was saved somewhere, and this minifix table was registered somewhere. So now the question is, all right, but where? Do we have Hive metastore in Synapse? And to answer this, let's get back to our workspace tab. So here we've got lake databases. Actually, let me refresh it. Oh, come on. Sometimes it refreshes, sometimes it doesn't. Great UI. So let me refresh the whole page. And hopefully we'll see something new. Yes. So we can see a new database here called PiotrTDemo. So that's the database that we created. And it is available here in UI under those lake databases. And in Synapse, lake database, it simply means this registered database that sits on top of files stored in a data lake. Just like those Hive tables from Databricks. And yes, we have our minifix table available. And we can compare this UI with our catalog from Databricks. So in Databricks, we would use this place. And I would have to start some cluster. So let me start it. And once it is up, I will be back and I will show you how it looks like here. Alright, so my demo cluster is up, and that's how it looks in Databricks. We've got this default, Piotr demo database, and we have this minifix table, something similar to what we just created in Synapse. But take a look that here in Databricks, if I click on a table, I will be able to see some of its properties. So I can see, for example, sample data. Let's just wait for the cluster to retrieve data from my data lake. I can see some details. For example, I can see that indeed it uses Delta format. I can see that it is a managed table that is stored in this Databricks data lake. So how does it look like in Synapse? So can I see some properties of this table? Not really. So how can I see where is it stored? Maybe on a database level? Nope, sorry. Can I see its format here somewhere? Nope, sorry, not possible. You have to write a code to retrieve this information. So let's go to Develop tab, and because I refreshed the browser, my data was lost. So my bad. I will have to quickly recreate all of the stuff. So one more time, what I did previously was to go to the raw container, then rubricable, minifix, and right click on your notebook and load to data frame. And let's run it. Hopefully the pool is already up and running, so it was faster this time. Alright. And what was done next was the most important stuff was to create this my data stuff. Let's run this and let's prepare this data frame 2 that contains our data, and that will be fine. That will be enough. So df2 equals to Spark SQL and then our query. And that's enough. Alright, so we have our data frame with data again. So what I would like to do right now is to check, alright, so where is this table stored and what file format it uses. So because there is no UI to help me with this, I will have to write a code. So I will switch to SQL and use describe table extended option table extended, and then the name of my table. So it is Piotr demo and then minifix. So let me run this. And here in this detailed table information, what I can see, actually I would like to see more data, is that the location of this table, location of the files, is like this. It's this Synapse stuff container on my Synapse ADLS table demo 1 data lake. And actually, that's my primary storage of this workspace. And I can prove it to you by going to this linked tab. That's my primary storage. And if I go here, I should see under Synapse, Workspaces, my name of my workspace, and then warehouse. That's the data for my database, PiotrTDemo, inside which I have my table called minifix. And then we've got our files. But it looks strange, because where is my delta log? Is it a delta format? Let's revisit our data. So no, provider is set to Hive. It's not delta. So that's another difference between Databricks and Synapse. Databricks by default uses delta format, while Synapse doesn't. And in case of Databricks, if we go back to our catalog, it was indeed delta. So that's important. So if you would like to save your data as delta, you will have to set it explicitly. So how did we create this table? Let me find the code. It was something like this. It was something like this, but we used df2. And to make it, sorry, not this one. Oh, come on. It was this SQL statement, right? Sorry. So SQL statement. So to make it work, or to make it as a delta table, what I will do, I will change the name delta, and I will tell Synapse explicitly, please use delta format. And this time it will save my data as delta. But again, it will be saved in this primary storage of Synapse, because I didn't specify any location here. So it will be a managed table. So it is the same behavior that we had in Databricks, but Databricks used its own data lake, while Synapse uses the primary data lake. But if we go to my tables, let me refresh it. This time I can see this new minifix delta. And again, if I take a look at its details, this minifix delta table, this time it will be saved as delta. So I had to make it explicitly. And also, if we browse the content of this primary storage here, yes, this time it is really a delta. We've got this delta log and we've got our Parquet files. So that's how it works, how it differs from Databricks. All right. So what we did next was to, well, what if we would like to create a table and register it as a table, but store it on our data lake? So let's copy this code that we used in Databricks and let's paste it to our Synapse notebook. So let me change a name to minifix. Actually, it can be minifix external. What I will change is the location to minifix synapse external. And we know that we have to set this format using delta, because I want to have my table saved as delta files, not as some default ones. And that should work. So let me run this. So this time, yet another table should be created and registered in my catalog in this under this lake databases. Yep, we've got this minifix external table. And if we query it, actually if we query its metadata, it was minifix external. This time we should see a different path that was used to store this data. And it is, yes, it's my Table Data Lake demo data lake. So this time it is saved on my data lake in a container that I chose, not in a primary storage. So again, let's use this integrated storage browser. Let's go into curated container, and it was this minifix Synapse external. So that's the place to which we saved our data as delta. So we've got delta log, we've got our Parquet files. So it works. Cool. Was there anything else? Well, obviously we could run all those queries that we used previously on our table, because after all, it will be executed by Spark. So if you don't use any feature that is available only in Databricks, it will work on Synapse as well, like this can't statement. So minifix external, yep, it should work, and it should result the number of our rows. And it worked. And that's pretty much it that I wanted to talk about Spark pools. So to summarize, if you don't want to use Databricks for any reason, but you would like to use Apache Spark in its managed version, so you don't have to bother with setting this Spark thing from scratch, then you can use Azure Synapse Analytics and Spark pools. And Spark pool is simply something similar to a cluster from Databricks. And then once you provision this Spark pool, your cluster, you would use notebooks to write your code. Something very similar to what you did in Databricks. But compared to Databricks, Synapse is way worse. It has less features, UI is worse, but it is there. So if you need this managed Spark thing, you can use Synapse if you wish. Now, you might start wondering, alright, so when should I choose Databricks and when I should use Synapse? From my point of view, that choice is pretty obvious. Synapse is a dead service. If you take a look at updates to Synapse, there are no updates. Of course, Microsoft will never admit that it abandoned Synapse, because it didn't. It is still supported, it is still there, and it will be supported for many years. But probably you shouldn't expect many new features added to Synapse. So if I were to start a brand new project that requires Spark, then the Synapse probably wouldn't be my first choice or the second choice. I would go with Databricks, most likely, because Databricks is still a leader in this area. Alright, and that was it for today. Thanks for watching and see you next time. Take care.